Hey guys, in this video, you're going to learn how to add, subtract, multiply, and divide fractions. Let's dive in. So these are the 5 topics we're going to cover in this video. We're actually going to start with multiplying and dividing fractions because they're much easier to solve. Then we'll look into simple addition and subtraction of fractions. And finally, we'll finish off with understanding the lowest common denominator, or the LCD, which is something we'll need when adding or subtracting fractions with different denominators. Okay, so let's get started. To multiply a fraction, we simply multiply the numerator by the numerator and the denominator by the denominator. So let's go with a really simple example. We're going to multiply 1/4 by 1/3. Following our formula, we multiply 1 by 1 to get 1, and 4 by 3 to get 12. And so the answer is simply 1/12. Now, you may be wondering, hey, that's great, but what does that number actually mean? Or how does that answer make sense? To answer this, let's use my favorite analogy, which is pizzas. So 1/4 would mean taking an entire pizza, dividing it into 4 slices, and then taking 1 slice, as the picture shows. Now, when you multiply that by 1/3, what you're doing is taking that original first slice, then further breaking that down into 3 more slices, and then taking one of those slices. It's like taking a slice of a slice. So now if you compare the final slice, which you see in the rightmost image, that slice represents 1/12 of the original pizza that you started with. And you can confirm that just by looking at the rightmost image itself. The newest slice is pretty small, or 1/12 to be exact. So that's how and why we multiply fractions, simply by multiplying the numerators with each other and the denominators with each other. Let's take a look at some more examples here. Feel free to pause the video at this time and attempt them yourself. I'll give you a second for that. Okay, so going with our simple formula, remember, we're just multiplying top by top and bottom by bottom. And so these are the answers that we get. Good job. Let's move on to division now. To divide fractions, we almost do the exact same thing as multiplying, except that we multiply the first fraction by the reciprocal of the second fraction. So first of all, what does reciprocal even mean? A reciprocal of a fraction is simply when you swap the value of the numerator with the denominator. So going with an example, the reciprocal of the fraction 3/5 is simply 5/3. Now, coming back to the actual operation, if we're dividing, say, 5/8 by 2/6, that would be the same as multiplying 5/8 by 6/2. And then we just follow normal multiplication rules from before to get us to 30/16. Same for another example. If we were dividing 2/5 by 3/7, that would be the same as multiplying 2/5 by 7/3, or 7/3, giving us 14/15. Once again, you may be wondering, this is great, but how does it make any sense? What's going on? For this, let us look at pizzas once again. So say you bought 3 pizzas for a party, and you wanted each person to have 1/4 of a pizza, meaning you have to split each pizza into 4 equal slices. So each serving is 1/4 of a pizza, or 1/4 of a pizza. Now, if you wanted to determine how many total servings there are, you simply have to divide your 3 pizzas into quarter-sized servings. Before we go the math way though, we can simply just count how many quarter servings there are in 3 pizzas. So counting them all, we see there are a total of 12 servings. And so going back to our fraction, we can get the same result by following our division rules. Let's first convert both of these numbers into a fraction. 3 is the same as 3/1, meaning we have 3/1 divided by 1/4. Now remember, we get the reciprocal of the second fraction. So we just flip the numbers, and now we multiply 3/1 by 4/1, giving us 12/1, or simply 12, which is the same answer as before. Now, let's look at some more example problems. Once again, I encourage you to pause the video and try it yourself. I'll give you a second for that. Okay, so remember, we're simply flipping or reciprocating that second fraction and then treating the problem like a multiplication problem. So these are the answers right here. All right, let's move on to the addition and subtraction part. For adding fractions as well as subtracting, which we'll see later, we're going to start with the simple case where the denominators are the same. And that is because when the denominators are not the same, we have to find something known as the LCD, but more on that later. For now, let's proceed with the simple case. So to add a fraction, when the denominators are the same, we simply add the numerators. So using an example, 5/8 plus 2/8 equals 7/8. Once again, you may be wondering, where does this logic come from? So let me explain. Adding 5/8 to 2/8 would be like adding 5/8 of a pizza to 2/8 of a pizza. And so what we're really doing is just adding 5 slices to 2 slices, giving us 7 slices. Notice that that's why the denominator remains the same. It doesn't become 7 out of 16 because that doesn't make any sense. You don't end up with 7/16 of a pizza. Instead, you end up with 7/8, or 1 slice short of a full pizza, which you can even visually see. Let's look at some more examples. Just pause the video if you want to try it yourself. They're pretty simple. I'll give you a second nonetheless. Okay, so these are the right answers. Moving on to subtracting, we're applying the same logic as addition, except that we are subtracting the numerators. And once again, remember, this is still for the case when the denominators are the same. Let's look at an example. We have 7/10 minus 3/10. So we subtract the second numerator from the first numerator, aka 7 minus 3, and we get 4/10. And similar to addition, let me paint you another example. I'll use ice trays this time. Let's say we had a 10 cube ice tray with 7 cubes of ice in it. And suppose you took 3 cubes away for your lemonade or iced tea or whatever. You would be left with 4 out of 10 cubes. And your resulting fraction is just 4/10. So that's the logic behind subtracting fractions. Take a look at these examples yourself and try to solve them. I'll give you a second once again. And these are the solutions. Pretty straightforward so far. Speaking of straightforward, we've kept the denominators the same so far, if you remember, because that makes the addition and subtraction very simple. But what if they're different? I mean, who said that they have to be the same every time? What if they look like one of these fractions? As you can see, these are perfectly fine fractions, so there must be a way. And as it turns out, there is. It's called finding the lowest common denominator, or LCD. So what does this intimidating sounding acronym mean? The lowest common denominator is simply the smallest possible number that both denominators of your fractions can multiply into. And that number is useful because it allows us to convert our original fractions into another set of fractions that have the same denominator. Once that happens, we can just add and subtract the old-fashioned way that we learned in the previous slides. So I know that may still be a bit confusing, so let's look at all of this in an example. We'll take 3/4 plus 2/6. Now the denominators are 4 and 6. So I'm going to first list out the multiples of 4 and 6. By the way, multiples are just numbers you get when you multiply your original number by increasing integers. So 1, 2, 3, 4, 5, etc. So 4 times 1 is 4, 4 times 2 is 8, etc., etc. And 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, etc., etc. Now, once we do that, we look for the smallest number that is common in both lists. We see that that number is 12. And so this just means that our lowest common denominator, aka smallest number that you see in both lists is 12. Once we have the LCD, I simply multiply each fraction by the multiple used to get to the LCD. So in the case of 3/4, the LCD 12 was the third multiple of 4. So I multiply both the numerator and the denominator by 3. Remember our multiplication rules from the beginning? This is why we taught them first. We just multiply the numerator by numerator and denominator by denominator. So 3 times 3 is 9, and 4 times 3 is 12, giving us 9/12. We do the same thing for the second fraction. The LCD, which is 12, is the second multiple of 6. So we multiply both the numerator and denominator by 2, giving us 4/12. Now we're almost done. Finally, we have two fractions whose denominators are the same, 9/12 and 4/12, which means that we can finally add them. Remember, when the denominators are the same, we just add the numerators. So 9 plus 4 is 13. So our final answer, after all this hard work, is 13/12. Let's see if you can apply that understanding to solve our problems from before. One final time, feel free to pause the screen and take a crack at it. Okay, so I'm actually going to go slightly in depth here with these answers, in case the concept was still a bit tricky. So let's focus on the first two. Remember, we just list out the multiples of each denominator. Once done, we find these are the LCDs. So we use the multiplication method to get them into equivalent fractions with the same denominators, and once that's done, we just add or subtract the normal way. Try the remaining two on your own. Alright, so these are the answers right here. Alright, so before we wrap up, let's do a quick recap of this video. Remember, we learned how to multiply fractions, for which we just multiply the numerators and denominators by each other. We learned how to divide fractions. For this, we just multiply the first fraction by the reciprocal of the second, and then treat it like a multiplication problem. And finally, we learned how to add and subtract fractions, for which there are two cases. First is if the denominator is the same, in which case we just add the numerators. And the second case is if they're not the same, in which case we find the LCD, then use that to make the denominators the same, and then just solve it like above. Alright guys, that's all I had for this video. I hope you learned a thing or two about fractions, and if you did, well then tell your friends, and I'll see you all here next time.